In this video, we'll take a look at running statistics on data in SoundCheck. Running statistics in a sequence, which we call online, is when you take the same curve, value, or result and get statistics on that same item over multiple runs. Every time the step is applied, either in a loop or consecutive runs, the statistics for that curve or value are calculated. For example, if I ran statistics on harmonic 2 and harmonic 3, I could get data out for each of those curves. Selecting the redo option from the menu will overwrite the last measurement, and statistics are recalculated to include the new measurement. For example, if I don't plug in a speaker on a production line, I run a test and the device fails. I don't want to include that failure in my yields for the day, so I could click redo, plug in my speaker correctly, and throw away that statistic that failed. Changing the following will reset statistics. When we run statistics on data, we have a couple of options. If we select max, SoundCheck will compare the current y and z value at point x with the existing point x. If the new value is higher, the maximum value is overwritten. For example, if I have at 1000 Hz, 90 dB. The next run, I get 93 dB, that will overwrite 90 dB, my maximum is 93. If the next run is 92, that's not greater than 93, so 93 is still my max. Minimum will compare the current y and z value at point x with the existing point, but if it's lower, the minimum value is rewritten. And mean will calculate the average y and z value at every x point along the curve. If it's a single value, we'll just calculate the average single value. When we're running statistics on curves or values, we can specify the work in mode. We can choose dB to do all of the math on the dB values, linear to apply it on the linear values, or power on the power values. What you choose will depend what you're running statistics on. Now let's take a look at setting up a statistic step in SoundCheck. I drop in the step, and at the top I can switch between data, results, or both. Right now I'll leave it on data. Then I can click, shift-click, or control-click to choose which data to take statistics on. I can specify to work in dB, linear, or power, and then which stats I want to run. For this, I'll select max, min, and mean. I run the sequence, and in the memory list for each piece of data that I have selected, I will get a new curve of value with max, min, or mean. I'll display all of these on the graphs where the piece of data exists. I'll add in a table where we look at the average sensitivity. And when we run the sequence again, it's going to update and show us all of these values. I run the sequence, all of this data gets populated. I can see what the min, max, and mean are for all of the data that I chose. If we zoom in on the fundamental, for example, I can see that I have the current run in blue, the mean in orange, which is in between the max and the min. If I keep running the same exact sequence, we'll keep calculating a new maximum, minimum, and average for each of these pieces of data. Here's an example where my amplifier was turned off when I switched devices. My fundamental is down to -1000, my sensitivity is -42. I don't want that new minimum in my statistics, and I don't want my average to be destroyed. I click on the start button, switch to redo, or I could click F4, and when I rerun this sequence, it throws away that last run and only will capture the new data from this run. So I gathered all my statistics, and let's say I got a new lot that I'm trying to test. If I change the lot number, my statistics get reset, and as I run, this new lot number will get the new statistics. If you see here in fundamental, the max, mean, min, and average are all the same exact curve because there's only one in the memory list. As I run the sequence more times, we'll see it update and show the new max, mean, and min of this lot. When running statistics on data, we can also calculate the standard deviation. This is a measurement of the dispersion of the y and z dimension of the selected curve or value. The more samples you take of this, the more accurate standard deviation becomes. When you enable standard deviation, you will then have to define sigma in the statistics editor. This will then add two new curves to the memory list, plus or minus n sigma. In a normalized distribution, 68% of curves would fall within 1 sigma, 95% within 2, and 99.7% within 3. You can also output the absolute standard deviation, which is the pure sigma value. Here is the calculation for standard deviation. This could be very helpful to run on a large batch of curves, then use plus or minus n sigma as limits for a production run. We'll open up the same sequence we were just using, but instead of max, min, and mean, we'll instead look at the standard deviation and absolute standard deviation. Once I enable this, I can choose my sigma in this field here. I'll set it to plus or minus 3 sigma. It gives me a warning that statistics are reset because I changed my statistics step. Now when I go and look in my curves tab, I can see plus or minus 3 sigma for every curve or value I have selected. I'll display those on the graphs. When I run the sequence once, they're going to be equal to the value or curve itself. But as I run more tests on different devices, you can see how my standard deviation curves change. Again, this will get more accurate the more tests you run and the more units you have. Now that I have some data in the memory list, let's look at the absolute standard deviation. I can compare this to what I was looking at with the plus or minus sigma displayed on the same graph and see the areas that deviate the most. Here in the high end under the fundamental, I can see that the deviation is much larger than at the low end, where everything is a lot closer together. In the next video, we'll take a look at the results in the statistics editor.